Okay, good afternoon, everyone. And today we will review our chapter 6, and also we will going to take our exam too. Um, After 7, or if we end our reviewing earlier than 7, the exam will start earlier. But don't worry, the exam 2 is easy. So let me formally begin. And in the long ago, we have touched something about the method, right? We have get to know the format and how to write a method. Like we should start from the modifier and the return value, the method name, method signature, or something else. But the one thing we haven't get touched is what is the difference between a static method or the normal method. And so today we are going to get something new and also reviewing for that. Well, we say that a static method is usually refers to a method without a without creating specific instance. For example, here we can see these slides. We only using the class name and then we using a dot to invoke the method name. So in this format, this is a static method. That's why. And let's get something in the first lines. So sometimes a method performs a task that doesn't depending on an object. That means we do not create an instance. No, we only using the class directly. That's the difference. And applies to the class in which it's declared as a whole. And so in this format, we say that it is a static method or a class method, but usually we use the static one. But if you are questioning what is a class method, you still have to know that it is a static method because it's belonging to the class. You don't need to specify an instance. So it's common for classes to contain convenient statistical method to perform common tasks. And one thing we should know that since it is a static method, so this keyword should be included in the method declaration before the return type. So let's go through next slide. One of the commonly used class method is the math something. The math class provides a collection of static methods that enables you to perform common mathematical calculations. And the method arguments may be constant, variable, or expression. Actually, in one of the examples we have mentioned earlier, that is the pi, math.pi. At that time, we don't talking too much about it because at that time we don't get into know what is a class. So I didn't introduce it to you. But now you have to know that for this, all these slides are all the methods belonging to a math. For example, if you want to use this method, you can write like this. For example, here it's using the apps is something, and in our coding is the full. Oh, sorry. You can write something like that. For example, math dot abs, for example, -23.7, right? We assign a float number or double. We say y is equal to. We do not need to create a math instance. We just call the math. And then the printout is y is equal to 23.7 directly. And for the other things, ceilings, cosine, exponential, floor, we use the same invoke method to call the statistics method. And this is for log and taking the max, mean, power, sine, square root, and tangent. So let's recall that each object of a class maintains its own copy of instances, right? A variable of the class. For example, we have a class that is a vehicle, right? Oh, shit. Why? Oh, I touched. And we can create some instance object like Toyota, right? This is the instance. This is the class. And each object of a class maintains its own copy of every instances variable of the class. That means the Toyota has all the, what's the problem? The Toyota has all the instance variables extended from the vehicle. However, this is a not statistic method. There are some variables for which each object of a class doesn't need its own separate copy, as you'll see momentarily, and such variables are declared statistic and are also known as class variables. So when objects of a class contains statistic variables, they are created, all the objects of that class are share one copy of those variables. That means even for the Toyota or maybe Santana, I don't know how to spell it, maybe like that, right? They may share something, share some common things. And those common things, we say they are class variables, and we do not need to create a specific Toyota or create a specific Santana. We just need to using the class, and then we can create such a variable. So together, a class statistics variables are instance variables are known as its fields. So you will learn some more about the fields in the later sections. And okay, let's coming back to the math class, statistics, constant pi and e. For example, we have mentioned some like log, sine, pi right there. And this is the math field for pi and e. Those are their naturally values that can be used for the mathematical calculation. And those things are declared in class math with the modifier public final and the statistic. And we have also mentioned something about final in the chapters 2 or 3. And there we declare a final constant using pi, but we are declare such value by ourselves rather than calling the math.pi there. So once we have using the final keyword, that means its value cannot change after the field is initialized. For example, if I declare public final static, okay, I will declare my own pi. Okay, sorry. Here, let me using double. I declare, I assign value. And after that, I want to change my pi to 4.20189. Okay, here it will go wrong because final is a constant, right? And the value cannot change after the field is initialized. So in this case, the program will go wrong and you cannot run it. And why a method is method main declared as statistics? As you can recall, we using the IntelliJ shortcut, right? IntelliJ shortcut, PSVM. This is the shortcut. And the S, it stands for static, right? And the main means the main method. And the JVM attempts to invoke the main method of the class you specify at this point. No objects of the class have been created. So that is another use for the statistic method there. So declaring a main method as statistic allows the JVM to invoke a main without creating an instance of the class. As we always practiced in our lab, what we will do is only PSVM, and then we can run our code, right? And there is no code like, for example, I declared an account and we say new main, right? We don't do that. We don't do that. We just create an account and then done. For the main method, we just leave it there. And that is the magic for the statistic keywords. And in our, when we are doing the practice for the multiple parameters we used in our main method there, usually we only have something like that, right? Let me write it. Main, right? And string args, right? And this is a brackets there, PSVM. And then we write our code. Here we only have one parameters. However, when we say declaring the normal method, before the lectures last month, we said a method can contain multiple parameters. We have a commonly separate list for that. But what we have to do is remember is there must be one argument in the method call for each parameters, unless we are writing a void method. A void method, you don't need to. Actually, it is not a void method. Is actually at this point I cannot recall anything that, for example, we have write the get method, right? Get name. And for such a method, the return type is string. And then we return name, right? Here we don't contain parameter. It is allowed, but usually there must be some arguments in the method call for each parameters. Usually, not always. And each argument must be consistent with the type of the corresponding parameters. And this thing we have mentioned in our previous lectures, because when we are learning how to declare a method there, we have also touched something about the formal parameters. And such a thing is also included in our exam 2. And when you are doing your exam 2, if you cannot remember what of them, you can turn to the slides in the chapter 6, the first one. You can go to the right space to find it out. All right, I cannot disclose too much. Okay, here let's have a look over this program. Here we are declaring a class to find the maximum numbers. So we set the class name as maximum finders. Okay, let's see here. We have a static, right? Because it is the main method, and this is the parameters, PSVM. Okay, and then we have our main method now, and in the main method, we do not need to create an instance. We just use it directly. Here we create a scanner for input from command window, and after that we give some prompt and input 3 floating points. Number here, the input next double, and this input will eat the first double, the first numbers we input in the command window, and this input dot next double will eat the second one, and this is eat the third one and give the number to the variable number 1, 2, 3. And after that, we are going to determine the max value. Here, we invoke this method. We say here we invoke a method, right? Okay, let's take a look over this method. Here, this method has 3 parameters, number 1, number 2, number 3. And when we are invoke a method, we do not specify the types for the parameters. But how about when we are formally define the method? Okay, let's take a look over the next slide. Okay, right. Here is the method definition. We use the static keywords to avoid creating an instance to using this maximum. As we can see here in the previous slides, we call it directly, right? We didn't do something like new maximum, right? Something like that. We didn't do that. That is because this is a static method. We don't call the new words to create an instance. We just call the method name directly, only because here the method, we have a static keyword there. And in the parameters of this method, we have 3 parameters there. And all the 3s, we declare them as double. That means for the parameters we are going to calculate, both of them are all in double type. And once we have done with the method signature, and here it's the main logic for the maximum numbers. There, we pass the value x to the maximum value, which is we declared in the first 26 line. This is a declared variable, and here we pass the value to it, and then it gives to the variable maximum value. And once we have the maximum value here, we say, okay, x there. And we compare y with x, or we say currently it is the maximum value. If y is over maximum value, we change the maximum value to y. And in this case, we no longer need x, right? So here x has been discarded. And then we compare z with y or x, because if y is smaller than maximum value, we will keep x as the value for maximum value there, right? So here we compare z with one of x and y. After that, if this is true, I mean, if z is over maximum value, and then the z will be assigned to maximum value, and y or x will be discarded. And after that, we return the maximum value. Maybe x, maybe y, maybe z. It depends on the logic flow. Okay, here we say, let's have a look. Suppose we enter 3 parameters, 9.32, 2.74, 5.1. Okay, let's get back to the slides. Okay, here they said that, let me change the color. If the x is 9.35, right? And 2.74. And the z is 5.1 here. Okay, now we have x, y, z, and they are corresponding to 3 different values. Here we initialize x as the maximum value. So currently maximum value is 9.25, right? And then we are going to determine whether y is greater than maximum value. Here, y, we say it is 2.74 over to 9.25. Okay, this is not valid, so we will skip to that. And here, we still keep the maximum value as x. That means it's supposed to be the 9.5, right? So, and how about z? Z is 5.1. Let's compare. But 5.1 is still smaller than 9.25. So here it is still not valid. So we will skip it. Skip to the last line of the method. Then it will return the maximum value, which is still referring to the x. So that means it is 9.25. So that's why the maximum is the first one. And for the second one and the third one, they are also sharing the same logic flow to get the output. So let's have a look over the implementing method maximum by resulting method mass.max. As we have mentioned that we can using the mass class, right? Using a dot and the method name to do something. Here, the mass is a Java collection of libraries. We can call them method directly using the class name. And the first specify arguments x and the mass.maxyz. That means here we are trying to decompose this nested comparison of the max value. Here we separate this one and this one. We are comparing x with the max.mass x, y, and z. And before any method can be called, its argument must be evaluated to be determine their values. So if an argument is a method call, which is referring to the nested method, max.max, y, and z, the method call must be performed to determine its return value. That means before we compare x and the mass.max, y, z, we should get the return value of this one. Goes first. This is our first step. And then we compare with it. This is the second step. So that means the first call is passed as the second argument to the other call, which returns the larger of these two arguments. That means the return should be y or z. And then it will compare the first step, and then it will compare with x. And there are 3 ways to call a method. We say using a method name by itself to call another method of the same class. Okay, we have to remember the same class. And the second one is using a variable that contain a reference to an object. Okay, here we have something maybe learn in the future or in your advanced Java class that is the reference to an object. But currently we do not need to know it. Followed by a dot and the method name to call a method of the reference object. And the third one is using the class name and the dot to call a statistic method of a class. Could we say, suppose this is a mass, right? This is a mass pi. And here we say we have like Toyota dot speed up. suppose we have a method that is speed up. This is a reference. This dot means a reference, and the Toyota means a variable we created from the vehicle. And for the first one, using a method name by itself to call another method of the same class. Well, it is a little bit different, but easy to understand because they are in the same class. They are using the same class. So maybe in our lab, we will demonstrate it. But currently, let's forget about it. And also, there are 3 ways to return control to the statement that calls a method. For example, here, when the program flow reaches the method ending space, okay, that means the program is naturally ended. And when the following statement execute return, that means you can put the return keyword in any place of the method. For example, here is your method, right? And this is your method. If something, and then you can have a return here. And then the program will stop here. No matter how many line of codes, maybe there is still an if statement, but it will not run because we have already returned at this line. And also we have another method that returns a result with a statement like return expression. We say, suppose we are going to return A plus B, over B. That means if A is 1, if B is 2 over B, so this will return false. However, we have to know that it is an expression. And that is the 3 ways to return control to the statement that calls a method. And for those non-static methods, they are typically called the instance method. We say the Toyota, right? Toyota dot speed up. Such a method are instance method because it belonging to the instance Toyota. A statistic method can call other statistic method of the same class directly, and they can manipulate the statistic variables in the same class directly. And to assess the class instance variables and instance method, a statistic method must use a reference to an object of the class. Okay, the word is a little bit lengthy, but you have to know that everything can be implemented as long as they are of the same class. Everything is the same class. So if they are the same class, well, okay, there is not too many barriers to access each other. And we also mentioned something about the stack data structures for the method. Last month, we say a stack is something looks like a bucket, and the things go down first in, right? First in, but last out. That means the things comes later will go out first. That is a stack. Here it gives in this slide gives us an example that it's analogous to a pile of dishes. A dish is placed on the pile at the top, which is referring to as pushing the dish onto the stack. A dish is removed from the pile from the top, referring to as popping the dish off the stack. That means for this process, we say it is push. For this one, we say it is pop. And that is a last in, first out data structure. That means the last item pushed in onto the stack is the first item popped from the stack. And for the method call stack, one of the most important mechanisms for the computer science students to understand is the method call stack. Actually, last month we have mentioned a lot of it, and we have split the method call with the method definition using the stack structure. And for the method call stack, it supports the method call and return the mechanism. And it also supports the creation, maintenance, and the disruption of each called method's local variables. And we also say that it is stack frames. Okay, I think here I should open in case you forgot about it. So let me open. Yeah. Here is the call stack we previously mentioned. Can you remember? Here we activate the record for the main method. We have some values for I, J, and we declared for K. And after that, we invoke a max method, and then we initialize something there. We pass the formal parameters number 1, number 2 to the method 25, right? I goes to the number 1, J goes to the number 2. We make them compare to each other. And then we return the result from the comparison, which is we say 2 and 5, the maximum is 5. So the result is assigned to 5. And we return the 5 to the initial frame of the stack. And once we have done with it, the stack is empty. That means the last frame is popped out. And that is for the last month, what we have learned about the call stack. Okay, let me go back to our today's slides. So here, let's review. For the stack frames, each method eventually must return control of the function that call it. We say there is the maximum, right? Maximum 2, 5. We have to return the result 5 to the function who call it. And each time a method calls another method, an entry is pushed into the method call stack. As we can recall for the slides we used in the previous lectures, and they are different in the call stack, right? This is our main method, and this is our max method, and we return 5 to the main method. And each time a method calls another method, an entry, this is an entry, is pushed onto the method call stack. And this entry called a stack frame or an activation record, which contains the return address that the called method needs in order to return the calling method. And if you are going to take in the computer architecture course, you will learn a lot of the details about the address and some other things. And we also mentioned local variable scopes in our last month's lectures. We say that when the method call returns, the stack frame from the method call is popped, and the control transferred to the return address in the popped frame. And that will form the local variable scope there. That means if you declare something, for example, I is equal to something, right? And the I will be go valid through the whole thing, through the whole line of program. And if you are calling a stack from, for example, here we say I, J is max 2, 5 here. Here we call the method there, right? And when we are calling the max, it will give us another stack. This is the max. Number 1, number 2. And this is our method there. That means when we are calling it, the control is going through such a way. We execute it and then we go back. And that is the control transfer. And there are also some issues. We say that it's a Stack Overflow. Well, you are not supposed to master it, but to just have a notion of it. The amount of the memory in the computer is finite. So only a certain amount of the memory can be used to store the activation records on the method call stack. If more method calls occurs, then can have their activation records stored in the method call stack. A fatal error known as a Stack Overflow occurs. For example, this is my memory of my computer, right? However, currently, I may have a lot of programs or a method. So this is a frame, this is a frame, this is a frame, this is a frame, and then this is a frame. Okay, in this case, this green shaded data here is overflowed. It is too much. So that is a fatal error. Usually it will make your computer stop or make your program stopped. Everything restart until you make it, you fix this problem. And that is Stack Overflow. And we are going to review something about the type conversion and the typecasting here. Although it is something typecasting here, we say that is argument promotion. As you can see here, converting an argument's value, if possible, to the type that the method expects to receive in its corresponding parameters. Okay, our first side of this line of sentence looks like, okay, it's converting something, right? Converting something unexpected to something we expected. So it is same thing with the type conversion. Conversion may lead to compilation errors if Java's promotion rules are not satisfied. Okay, usually if you promote a low level or small range of type into a long range type, it's fine. But usually if you are going to convert it from long to short, okay, maybe it may lead to some errors. Maybe. And the promotion rules specify which conversion are allowed and apply to expression containing values of 2 or more primitive types and to primitive types value passed as arguments to methods. And each value is promoted to the highest type in the expression. Okay, here are those primitive types. As we can see, we have some. Actually, we are pretty familiar with the type, right? Double, float, long, int, char, short, byte, boolean. This is from long range to short range. And what it can do is that promote it, right? Becoming longer, 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 longer. If it is converting from the longer direction, okay, it is fine. The program will not go wrong. Usually the program will upgrade the primitive data type in the longer direction, usually. Okay, let's have a look over the Java API packages. As Java contains many predefined classes, as we know that for one of the most common is the math, right? If you can remember that scanner is also the predefined. And those we call they are packages. A great strength of Java is the Java API has thousands of classes. But this is also a problem since Java has a lot of packages, they have a lot of APIs, so it's quite difficult to master everything. But one thing you have to know is that you know how to find the APIs. Usually you can click on the link and go to the summaries and find the things you are looking for. And in the documents, they will give you a detailed description how to use the APIs and what is the parameters type, what is the return type. Everything is listed there. And here there are some common packages for this one. So auth. Okay, actually we don't use it anymore. We have some more advanced packages instead of using the abstract window toolkit, but just giving you an example. And for the .java.io, okay, in our chapter 15, we will using it for frequently because we'll have to using the IO to read something and output something through file rather than the command line. That means we may create a file containing something using the notepad, and we read the content from the documents directly rather than we using the scanner to read the user input. And those are the common Java packages. Okay, here for the declaration of the scope, okay, let's recall something. Declarations introduce names that can be used to refer to the Java entities. And the scope of a declaration is the portion of the program that can refer to the declared entity by its name. Such an entity is said to be in scope for that portion of the program. The basic rules is the scope of a parameter declaration is the body of the method in which the declaration appears. The scope of a local variable declaration is from the point at which the declaration appears to the end of the block. Okay, we have to know this is for the parameter. This is for the local variable. And also the scope of a local variable declaration that appears in the initialization section for a full statement header is the body of the full statement and the other expression in the header. Well, actually, you will have a problem, have a question of the scope of the declaration in the exam too, but it's okay. I don't think it's difficult. It's quite obvious there. And a method of field scope is the entire body of the class, entire body. So any block may contain variables and declarations are the scope of the such things. If a local variable or parameter in a method has the same name as the field of the class, the field is hidden until the block terminates execution. This is called shading. Okay, let's have a look over this. Here, the field is, we have declared a private static int variable x, and we assign 1 to the x. That means the scope for the x is from the line 6 to the last line of the program, which is 40. And then in our main method here, we have another x there, right? This is a local variable x, shadowed field x. So how about for this? Let me change the color. How about for this x? So since it's declared from the line 11, we should find out where is the end of the main method. Okay, as we can see, 20 is the end of the main method. So this is the scope for the x inside of the main method. And for the outside main method x, its scope is from here to long far away here, right? That's the scope. And here we also have some method, use local variables, use field, use local variables. Those are method without parameters. Let me write something. As you can see, no parameters, right? We just call the method. Here, why we here it is the local variables method. And that's it. That's the scope X. And also we have something about the method overloading. That means for the parameters we write in the same name of the method class, we can declare different types of parameters there. And the compiler will select the appropriate method to call by examining the number of types. For example, we may have a max, right? Int num1, int num2. And also we can have another method that int double number1 and int number2, right? This is overloading. The compiler will select the appropriate method by calling examination the number, types, and order of the arguments in the call. What we have to do is to define it is enough. And we can use the method overloading to create several methods with the same name that perform the same or similar tasks, but on different types. Okay, the only different is the types or different numbers of the arguments. Literal integer values are treated as type int. So the method call in line 9 invokes a version of square that specifies an int parameters. Let me see, line 9. Okay, here, great. They gave us an example here. In the line 7, it calls the method square and pass an integer, right? And here it pass a double one. So we say this is the method overloading because they have the same name, right? Same name, but they have different types of the parameters. So that is a certain kind of example of the method overloading. Here, the compiler will decide, since square 7, we have an integer here. So the compiler will select the first one to compute the square for the 7, because here it is the int. And when we are executing the line 8, and the compiler will be noticed that, okay, the parameter is a double, so I should match a double type for the square method. So that's why the first one calls the first square method and the second one calls the second. That is a method overloading. So here is the output for the example. And we have to distinguish between overload method because the compiler distinguish overloading by their signatures. We say the method name plus parameters. Oh, here, and types orders. And the return types of overload method and the method call cannot be distinguished by return type. Only by the signature. Okay, figure 6.10 illustrates the errors generated when two methods have the same signature and the different return types. And the overload method can have different return types if the method have different parameter list, and it need not have the same number of parameters. That means we don't have the 6.0. This is 6.10. Okay, here we have the return type is integer value plus integer. It's supposed to be integer, right? And here double multiplied by double is supposed to be double. Currently, I cannot see any errors, but he says that there might be some errors. I don't know. So this, I don't think this is valid. So we have to forget about it. And overload method can have different return types, of course, if the method have different parameters list. What we have, the only different things is we have to remember is the signatures. They should be different. And for the method, it depends, for the return values, it depends on the things we are going to return. So we are not necessarily should have the same return types for the method overloading. And that's all for the review for the section chapter 6. So next, I would like you to go to the exam 2. Let me find it. I will post it. Okay, I hope you can find the exam now. In the assignment here, I upload the exam too. Not too much coding, but I have some questions for you. So you can do it now and take free time. As long as you can complete, you can submit it. And for those people who are not coming today and who are not taking the exams today, they still have some time, but I will give some penalties on the examinations. So for those students who are attending today's course, as long as you can make the answers close to the answer, you will get 4 marks. Okay, let me know if you have any questions regarding the exams. I can explain. Okay, go ahead and taking the exam too. And I will end the recording.